Hi, guys. My name is Mathieu Tuli. I'm a machine learning engineer at Meta. And today I'll be talking about the pixel economy and sort of really building generative models at scale for taste and doing this at speed as well. Now, I did borrow this term, the pixel economy, from Chris, the CEO of Runway. And really what I want to kind of get at is how we're thinking about merging research and product, and specifically in sort of generative modeling. So I work for the Media Foundation team at Meta. We work mostly on sort of media ingestion, processing, and delivery, and mostly myself and my team on AI creation, media enhancement, and intelligence, and then finally sort of things like generative model optimization as well. And so really day to day, that sort of looks like this. We build a lot of feedback loops. We build different data pipelines for that. And then we do a lot of training and modeling, and then finally deployment of models and all the kernel optimizations that go with that and things like that. And so we do this as well at the sort of scale of billions of media a day. And so how we handle that and how we handle sort of things like virality is sort of what I want to get to. And so today, I want to talk about the pixel economy, sort of the conflict between research and product and trying to get research outputs quickly into product and product feedback back into research, the role that data plays in that, and then finally sort of look at how we're thinking about solving some of these problems, mostly with data in sort of the bittersweet lesson, and then how we're thinking about the alchemy of training to deploy these models, and then finally where I think we're going with tuning for preference. So just to ground us in sort of an example for this talk, I would sort of want to introduce what we're calling the Media Foundation Video Generation Model, or MFVG. This was sort of a stylized transition first last frame animation model that we built in the first 2 months of the year, ultimately designed to replace these large 20, 30 billion parameter transformers with a small sort of single digit billion parameter model that can run in under 10 seconds at 720p. And ultimately, this sort of represented a 13x speed up over these baselines. And like I said, this was developed in 2 months to beat out baselines like Midjourney. And so this model basically just allows us to take images, like I sort of show in the top left, and generate these sort of really cool stylized transitions that you can, make to either animate images like this case, or even generate fillers in between different videos you might have. Okay, so the pixel economy, what do I sort of mean by that? I mean, really, there's nothing secretive here. The pixel economy is just the business of selling pixels to people, to consumers. And the way we're thinking about it is how we're building next generation media experiences and doing that for users at scale. So that's everything from AI creation to how we're thinking about personalizing consumption, to how we're enhancing media using AI, and really just how we're converting RGB values to intelligence. And so the trend from research perspective on your ability to generate media with AI has sort of followed this exponential curve, right? Incremental improvements in research have just sort of snowballed into this exponential behavior. But product has always sort of lagged in this step function behavior behind it. A lot of that is because distilling research into product, optimizing models for deployment, putting it in front of users, figuring out what's sort of catching on and what isn't, is a very slow process. And so things have always sort of fallen this step function. And I sort of see us now today here where, in 2022, around that time, we sort of got the Sora models of the world. And we got this sort of rise in the ability to generate videos and images in sort of this new way, in photorealistic way. But we're sort of, we haven't really seen much, I guess, progress on the product level about what these things are really going to be doing for us. And so, unless we sort of reel that in and figure out how we can tighten the loop between what's producing in research and the benefits that are coming out of some of the newest models and how we're actually deploying these to users, I think we can sort of start tailing off if we don't tighten that loop quickly. And so I want to talk about how we might be able to do that today. And again, for provenance, this is a graph I took from Chris, so feel free to check out his blog on this. I think it also adds a bit more color to this idea. And so the reason I think we sort of see this step function approach as well to product and product progress is because of the way that these things are sort of conventionally built in sort of a linear manner. And really what happens is we sort of get these two isolated loops between research and product. So the research team builds data sets, and trains the model. And the product team deploys that, collects feedback, and then tries to update the model or their product rather to according to that feedback. And a lot of this sort of siloing of the two loops is because of the distribution of roles, I think. The research scientists are really focused on the research side, the software engineers are focused on that product side, and you have your AI engineers sort of in the middle, bridging the gap. But there's sort of a lack of consideration or a lack of understanding for the research group to know what the product needs, and what the product group knows how the research cycles work. And you have this sort of one-way communication where feedback from users and creators flows back into research, but it's not really sort of harmonious, and the different components of this pipeline don't really communicate well with each other. And so just to sort of allude where I want to sort of get to is the sort of the visual that I think is super helpful, right? Where we sort of have tightened this loop and closed this loop where all aspects of the end-to-end deployment of these models are influencing each other, and research and product effectively become the same thing, right? So feedback distills directly into how you collect and refine your data. Your deployment conditions define how you train your model, and all of this is sort of interconnected in this nice way. Okay, so ultimately the questions I want to answer are effectively the following, right? So how do we merge research loops and product loops? How can we, like I sort of showed with the stylized transition model, how can we distill and define stylistic preference and allow them to become models? And how do we handle creation boom as different people want to create different things and different stylized transitions? And how do we keep up with viral trends as people explore these models and figure out new ways of generating content with them? And sort of how that creation consumer economy evolves over time. And so the first stage in doing this, I think, is what I call the bittersweet lesson. So the bitter lesson, for anyone that doesn't know, is sort of a blog post by Richard Sutton from 2019 that basically identified that modeling and handcrafted bias is largely has little effect compared to scale. So scaling your model, scaling your data will always lead to better quality, more emergent behavior, and all your efforts should effectively go into figuring out how to scale. Now, where I think the sweet part of this lesson comes in, and so yeah, I guess just to mention that I think has held true really for the past 7 years, and everything from robotics and world models and media intelligence has seen greater and greater quality and emergent behavior with scale. And so the sweet part of this is where we can now reintroduce handcrafted bias with taste, and specifically for personalized experiences, but in this case, I'll focus on media generation. Taste is sort of that last 20% that allows you to redefine your model and introduce new features and interesting ways that you can interact with them at the product level. And so I break this down into sort of two stages. The scale allows you to build interesting backbones and interesting model capabilities through pre-training. You can access the internet and all your archival data and pre-train this to have emergent behavior. But then your product or your moat is effectively how you post-train the model, how you distill it, how you optimize it in a reinforcement learning loop to introduce new behaviors that weren't there in your data in the first place. Now, for our sort of media foundation video generation model that I was talking about, we follow the very similar pipeline, right? So we collected a bunch of diverse scenes, motion quality, human-focused data to sort of pre-train the model for this first and last frame animation task. But a lot of that stylized transition that you saw where the morphing of the subject and camera motion ultimately comes in how we curated our fine-tuning data sets and built that into the product that ultimately we ended up shipping. And so, the concept of taste, I think, is very subtle. It's sort of the difference between this image, very generic image of the Golden Gate Bridge that I took, and sort of this maybe nicer, more corrected, color graded version, right? So you have, neutral tones and blues here, and then nice sort of sunsets coming in and nicer colors. And so taste, I think the kind of idea I want to get across here is that it can be built. It can be the moat or the product that you ship. It's the data pipelines that you build. It's how you define the recipe for distillation. And it's how you tighten that product feedback loop, which, to allude to here is how we can build reinforcement learning here and really tighten that up in the future. So just to take a step to the side here, how we did this and how we solved for taste in our stylized transition case was pretty manual and pretty simple. So to sort of start at the bottom, actually, we built this training loop effectively that allowed us to iterate really, really quickly. So we defined a training set. We had a recipe for training that was pretty fixed. And then we developed what I call sort of the taste anchor or the golden evaluation set. And this allowed us to sort of iterate over many rounds to train a model, A/B test it, and then figure out where the gaps are or where the artifacts from training are and sort of prune those out. And so the thing here is that there's no metric for taste. It's very subjective, and it required sort of over the course of a month, many rounds of manual refinement to really hone in on a fine-tuning data set that really represented exactly what we needed and defined the sort of the qualitative aspects of the product that consumers really wanted. And so this taste anchor was co-developed between the research and the product team to sort of have a nice blend of technical capabilities we needed out of the model, as well as qualitative aspects that really no metric can define. And in doing so, we were able to have a reliable benchmark that allowed us to move relatively quickly, but still took a while to sort of refine that data. And the refinement is pretty subtle, as I sort of mentioned, right? I can show this image or this video of the Sphinx and the pyramids, and although it looks kind of nice, you'll notice that the pyramids reappear in the background here, and the initial pyramid we saw actually shot off to the right. And in this case with the horse, the camera is quite shaky, even though the subject morphs quite nicely. And then in this case with Michael Jackson and so the Jackson 5. You see sort of stringy text that kind of appears across the screen, and you can see on his chest there's sort of some visual artifact and sort of almost tessellation. And so at first glance, these seem promising. These seems like good samples to train on, but these sort of some subtle issues in quality distill down into your final model. And so over iterative refinement, you can sort of prune these out, and that had the biggest ROI for us in terms of improving quality of the model in the end. Okay, so moving on from data, sort of what I call the alchemy of training. And the alchemy of training is just sort of this notion that, building machine learning models is much more of an alchemy than it is a defined science. We often in this space work in retrospect. We try some things, we see what works, we see what sticks, and then we figure out why. And that sort of feeds that step function as well, because we're always sort of iterating in this manner. But your training good models, ultimately comes down to how you define these recipes and how you define taste for training good models. And you can build that intuition, I think, through experimentation. And so having loops, like I was mentioning, that are sort of fixed, allow you to sort of iterate really quickly and tune the data and know what aspects of the data that you tuned had the biggest impact on quality. And so that allows you to, hopefully model things like virality and chase trends along the way. Now, the concept of recipe isn't new. Andre Kaparthi, also from a blog in 2019, sort of introduced this idea. And I think it's sort of good to illustrate because this is largely how we still train models today. And the first stage here is just to become one with the data, have an intuition for it. You should be able to predict what your model is going to do even before you go out and train it. Then you want to build these sort of end-to-end training and evaluation pipelines and what he calls the bare maximum baselines. And then you want to show that those can work and those do overfit. And once you've done that, you can regularize and you can scale it. And then the last two stages, I think, are where what's more interesting is now we can finally tune our model towards our product and sort of squeeze any performance out of it. And so I break these down again into those pre and post training phases. I've added data to the tuning stage. And I think the key here is we really want to tighten our feedback loop so that as we're squeezing performance, we are tuning the model and the parameters and the data and sort of iterating in this way to sort of maximize quality. So graphically, that kind of looks something like this, right? Scale feeds pre-training, gives you the baseline capabilities of your model, and then taste defines the post-training loop. And generally for us, and in the media space, there's two axes you can control. There's one for latency, which is ultimately model distillation, and then the other one is how you tune for preference and what you want your product to be. And I see sort of reinforcement learning coming here as that second component. And then, of course, you can ship it. And so for us in the Media Foundation video generation case, latency was top of mind. I think one of the biggest things we saw was even 10 seconds was too long for creators, and no one really wants to wait even any longer than that. And so the previous model was ultimately about a couple minutes to take to generate a video, and so the biggest thing we were focusing on here was a really aggressive distillation of the model, going down from 50-step diffusion models to 4-step diffusion models. And this had the biggest impact for us in terms of the customer experience. But it does introduce or it does degrade quality in certain axes. And so reinforcement learning also allows you to reintroduce those. And I'll sort of talk about that in a bit. And so the last point I just want to mention on training is this notion of training to deploy, right? So I think this is sort of lost a lot of times when you have these silos of product and research teams. But deployment should always be defining the conditions for how you train your models. The serving constraints, what these latency constraints are, the hardware you're going to be deploying to, these should all be considered into training dynamics, and oftentimes they aren't. That feedback loop, right? How you're collecting that feedback from the consumer, how you are refining the data, that defines a lot of how you actually should, train your models and build data sets. That is ultimately the end-to-end product, and so that should be really considered in how you train and how you build your training pipelines. And then for latency as well, there's other things like quantization-aware training and sparse attention that can only be considered at the training level. And so having a tight interaction between product and research is super, super important to build models that will actually get in front of users. To sort of start off now where I think we should be going with this and moving away from sort of this manual effort required to training models these days is that, squeezing performance has a cost. When we went from, this 20 billion parameter model to our sort of small single digit billion parameter model, you do lose a lot of quality in squeezing that out. And so then it's really important to have high quality data, as I mentioned. But that data is super expensive to generate, to refine. And you can destroy some baseline capabilities in that process, right? So prompt adherence, for example, for us was one thing that sort of fell off quite significantly. Now that didn't totally matter in this case, but in future cases where we want people to be able to prompt these things, that does become a problem. And so reinforcement learning offers now a cheaper solution for us. You can amplify taste with preference tuning. So rather than collecting data that we think aligns with users, we can just let the model generate samples and see what people actually like, and then use that as a signal to train our models. We can introduce novel motion or effects with VLMs that the data maybe didn't represent, like fireworks coming across the scene or cameras rotating in sort of strange ways. And we can now realign the model towards target distributions like prompt following. And basically just replace months of data refinement with a reward that can model your taste. And doing that is pretty straightforward. VLMs, the first stage here is to build a reward. VLMs are super great nowadays at understanding content and rating it. And this sort of surpasses that metric gap. You don't need a metric for every axis of quality that you want to define. All you need is interesting questions to ask the model. So we can sample, we can ask things like, does the subject morph and does the camera have smooth motion? If yes, then we reward it positively. If no, we sort of penalize that. And you can imagine all the different questions we can ask in terms of whatever your product use cases are and the sort of types of videos you wanna generate. And so I sort of see then this world where we can really tighten the loop and sort of build these things on demand. So to sort of go through an example here, a trend might go viral. Something about these sort of huge baseline models that we have might surprise us. And so we can detect that, and then we can capture that in sort of a reward model. And then spawn an environment on demand that distills and then preference tunes that model with reinforcement learning to sort of compress that capability into a small specialist. And then we can start serving that at scale, right? As I mentioned, these big models take minutes to generate, which doesn't really work at scale. So having these small specialists that can follow trends and be discarded just as quickly as trends die, I think would be sort of this, introduces this interesting idea where the product itself is sort of dynamic and ever evolving and following the way people are consuming and following sort of this sort of viralness of media. Okay, so what's next? I think it's just that, right? RL offers us a way to convert these stylistic preferences into models, and basically allows us to continuously learn rather than trying to build new algorithms or try to have bigger and bigger models that hopefully can represent every possible combination. Building these sort of small specialists on demand is sort of a form of continual learning that we can just as quickly build and forget about. And we can act on these trends in this way, and we can even enable creators to sort of tune some of these models to sort of their preference and offer that as a new experience. and sort of bring sort of what I like to call creative determinism to sort of a world of uncertainty and probability. Now, sort of the last point I want to mention is that I think the roles aren't going away, but the roles do need to converge at the knowledge layer. And I've sort of represented this graphic intentionally where, the research scientist and the AI engineer are still operating at that low level. They're still training the models. They're still working on that deployment. They're still taking feedback and refining data. But the software engineers are sort of existing on the outside and building the systems that allow this to sort of work in this unified way. But the key here is just but all these roles need to have an understanding of each responsibility end to end, right? You can't know how to train an efficient model if you don't know the surface it's going to be deployed on. You don't know if it's going to be quantized or not, and vice versa. You don't know what, as a software engineer, what feedback to generate and collect if you don't know how that's going to influence your data and your training as well. And so I think that's just an important point I want to hit home. Yeah, lastly, discover latency. I think a lot of this, mostly just like this graphic, but it's mostly just to mention that, all the things I'm talking about really don't matter if you don't have an interest and a desire to sort of build interesting visual experiences and sort of explore the way that these models can surprise us. And I think that that is an important sort of habit to get into, is to just sort of discover what these models can do for us and explore them.